Hello, and welcome to Shane's Microscope. I'm Shane, and this is my microscope. Let's take a peek. Today's sample comes from this drainage ditch. There was an interesting brown sort of sludge that was on all of the rocks, and when you have a microscope, sometimes you want to investigate stuff like that. So I put a little onto a slide with some water and dropped on a cover slip. Well, let's find out what's in that stuff. Under the microscope now, that stuff doesn't look nearly so slimy. We can see some small rods. And now at slightly higher magnification, we can see that these are diatoms. Diatoms, if you recall, are of the class Basilariophysea. That comes from the Latin basilis for little staff, and the Greek phycos for seaweed. Under really high magnification, we can see that we've got several different types of these little guys. They are definitely three-dimensional, so changing our focus lets us see different parts of them. And there are just so many forms. We've got little ones, we've got big ones, some have little knobs on the end, some are long and thin, some have a bit of a wave to them. Now, as we investigate these little things, if you didn't know, diatoms have a shell of silica, and in fact you can see an empty one over on the right. Those silica shells persist long after the diatoms are gone, and that's what diatomaceous earth is made out of. Now, you may have heard people say that the silica shell is like glass, and in some superficial ways it is like glass, and it does have the same chemical composition as glass, but saying that the shell is made out of glass would be like describing a diamond as graphite. You know, the chemical composition is the same, but it's a completely different form. So I think it's actually even cooler that their shells are made out of quartz. So quartz and the glass that you see through can have the same chemical composition, but the glass, by definition, is amorphous. It doesn't have any structure to it, and the quartz is crystalline, so the atoms are ordered. Oh, this interesting multi-part semicircular one is Meridion circulare. The genus Meridian comes from the Greek meris, a part or a portion, and it's the species circulare from the Greek kirkos, circle or ring, which is the same root as circus. And this one here is of the order Naviculales. That's from the Latin navicula, small ship, from navis, ship. Oh, check that out. We've got an amoeba. That comes from the Greek amoebe, for change. Well, I thought this sample was oops all diatoms, but we've got another thing in there. And that interesting filament there is bacteria. That comes from the Greek bacteria, which means a rod or a stick. And that's related to the Latin bacillus that we discussed before. Those diatoms near it are of the genus Nitzschia, and they're named after the person who discovered them, a German naturalist named Nitsch. And you can also see that some of those nearby diatoms are covered in growths of bacteria. Interesting. I also saw this little flagellate flagella, recall, is Latin for whip. Doesn't seem to be really doing anything, but you can see the flagella. And here's a ciliate. Cilia is Latin for eyelash. And I don't know what type this is, but it's interesting to look at. This here is Melocera varians. That was a type of diatom that we saw last time. Its name comes from the Greek melea for melon and cera for chain, and varians comes from the Latin varius for various or varied. Here's another diatom of the order Naviculalis. I think it's really interesting just how many different shapes and sizes of these diatoms there are. They're really a diverse class of organisms. And just as I was getting ready to close things up, I noticed this. Well, not that silly, we'll get back to that. But this interesting thing is a heliozoan. That comes from the Greek helios for sun. It's not hard to see why. It's got a whole bunch of rays coming out of it. Those are used for hunting. Oh, look at that. Huh. It just released some kind of vacuole. And then nearby, we had this little ciliate. It's very active and very interested in the bottom of the slide. Had some difficulty following it and identifying it, but it looks like it's been eating some diatoms. Well, I thought this was really interesting. I was not expecting that brown slime to be full of diatoms, but it sure was. Big ones, small ones, crazy shaped ones. Neat. Alright, well I think we'll leave it there for the day. Thanks for having a look with me. Until next time, keep on peeking.